Well, hi students, I'm Dr. Thomas, and this video is on how to multiply and divide rational expressions. Let's start with multiplying rational expressions. Here are the steps. So if you memorize these steps, you should be okay. So the first thing you do will be to factor numerators and denominators. So in this situation, you factor everything. As you recall, with adding and subtracting rational expressions, you actually just factor the denominators. But for multiplying and dividing rational expressions, you're factoring everything and canceling out common factors. Which brings me to step 2, multiply numerators and denominators. Step 3, cancel out common factors. And step 4, simplify. First example, 2x squared plus 4x divided by x squared minus 4x minus 12. So we have that expression times this next expression, x squared minus 9x plus 18 divided by 2x. So the first step, of course, is to factor. Factor. You factor everything in sight when you are multiplying and dividing rational expressions. So if you factor 2x squared plus 4x, you get 2x times x plus 2. I always make sure that you take the GCF out first. That's regardless of anything, you have to take the GCF out first, or you will probably get the factoring wrong. So make sure you do that. And I recommend you also pause the video and try to factor out the problem before you see it being done. Okay, so I will pause and do beforehand to see if you can get it right. Alright, so for example, the denominators, see if you can factor and get that correct. So you have x squared minus 4x minus 12. Go ahead and factor that. Pause the video and let's see what we have. Okay, from that x squared minus 4x minus 12, we get x plus 2 times x minus 6. And always multiply what you see here to make sure that you have indeed the correct factors for x squared minus 4x minus 12. Of course, we can't factor 2x. Alright, now this step says multiply. Now in this step, it's only trying to show you that because it says multiplication, that we multiply numerator times denominator, and numerator times numerator and denominator times denominator. So excuse me, numerator times numerator, denominator times denominator. That is essentially the rule for multiplying fractions. You just multiply. Essentially, you just multiply the numerators together and you multiply the denominators together. So this step is just showing you for rational expressions it works the same way as well. You don't have to do this step. You don't have to put it all together like this, because it's really a waste of time to put it all together like this. But this is a good step to show you so that you'll know all of this means. This step, this first step here, is equivalent to the second step. We're just putting everything together. Alright, and the third step would be to cancel out factors. Now we saying divide, but that x plus 2 divided by x plus 2 of course is 1, for example. But we, in our terminology, we say cancel out. The x minus 6's also cancel out, but also the 2x over the 2x cancels out. And what does that leave us with? Simply x minus 3. So that is your answer. Let's look at another example. 6x squared plus 18x divided by x squared plus x minus 6 times the rational expression x squared minus x minus 2 divided by x squared minus 7x minus 8. Again, I recommend that you go ahead and factor all numerators and denominators if possible. And once you're done, check back, okay? So the factors are 6x times x plus 3 And that the other numerator, x squared minus x minus 2, factors to x minus 2 times x plus 1. And here are the factors for the denominators. Now again, see this step right here? So they're showing you that these two are essentially the same thing. They just put the numerators together, right? So they didn't put this, see this wide space, they just put it together instead. And now at this point, you should be able to see that these are equivalent, and if you cancel out, you get the simplified result. So what cancels out? X plus 3, x minus 2. Anything else cancels out? Yes. X plus 1 cancels out. So the final answer is 6x over x minus 8. Now remember that we cannot cancel x and x out because we cannot cancel terms. So this x is a term. It's separated from the other term by a minus or a plus, so you cannot cancel those out. You only cancel out x's when it's the multiplication property is going on. In this case, this is not multiplication. This is x minus 8. Alright, let's continue. Here we have an example: multiply a rational expression by a polynomial. So x minus 4 divided by x cubed plus 1 times x squared minus x plus 1. Now what do you see here? You see that it's just a polynomial. Now what we always recommend is that you go ahead and put that over 1. Alright, if you want to see it as a fraction, you always put it over 1. And now it's our job to factor, if possible. Is it possible to factor this? It looks very strange to me. Now, this is important. Don't try to make something factorable when it's not factorable. Alright, this x squared minus x plus 1. Are there factors of 1 that add up to negative 1? So that was pretty much impossible to do. Alright, so if you notice the x cubed plus 1. Now I'm gonna have to break that down because that was a little confusing, right? Let's break that down. So let me put a space here. We have to factor x cubed plus 1, and if you're really getting good at factoring, you should have already noticed that x cubed plus 1 is a sum of cubes. And yes, a sum of cubes is indeed factorable. Okay? So you need to know the formula. Go to the book, you get the formula, browse through your notes to get the formula. But the formula is a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So your job is to figure out what is A and what is B. Alright, so it looks like our A will have to be x and our B will have to be 1. So because 1 cubed is 1 and x cubed is x, we just need to figure out what these values are for A and B, and it's pretty easy. So now that we know A is x and B is 1, we can just replace the A's with x's and the B's with 1's. So here is the factorization or complete factorization for x cubed plus 1, and this is where this came from. See that? So that needed to be explained. That is why these two cancels out, because that happened to be a factor that was in x cubed plus 1. So the answer, of course, is x minus 4 over x plus 1. Alright, moving on to dividing rational expressions. What you essentially need to know the most for dividing rational expressions is that you flip the fraction, or pretty much flip the fraction. Factor, divide, simplify. So for example, I know that division symbol looks a little odd, but that is the division symbol. This is the division symbol here. We are going to keep, change, flip. So notice that we keep the first fraction the same. Alright. We change this multiplication symbol to a multiplication symbol, and we're going to flip this. And notice when we flipped, the denominator is now in the numerator and the numerator is now in the denominator. Then we factor everything that's in sight. And so the x squared plus 6x minus 7 factors to this. And if you multiply this, you'll see that those are the factors for x squared plus 6x minus 7. And in the denominator, ax squared minus 8x, it does have a GCF, 8x, and it factors to this part. So they just put everything together, which is the same thing as if you did not put everything together. But you just know that it is 1, right? And then we cancel all common factors. When we cancel all common factors, we will simplify, and we get the answer 3 over 8x. Alright, maybe another example. X minus 5 divided by 9x squared minus 18x divided by 2x squared minus 11x plus 5 divided by 2x squared minus 5x plus 2. So, recommend that you keep, change, flip. Everything is together at this point. It means the same thing as if you had to separate by a multiplication symbol. Now we factor everything. Alright, notice that 2x squared minus 5x plus 2 factors to 2x minus 1 times x minus 2. And if you want to really make sure, always multiply that out. Also notice that 9x squared minus 18x factors to 9x times x minus 2. And two x squared minus 11x plus 5 factors to 2x minus 1 times x minus 5. Now that we factored everything, cancel out common terms. And this is a good one here. So notice that all of the terms in the numerator canceled out. But I need you to realize, since this is division, that you'll always have a 1. For example, if over here, if I wrote out 5 divided by 5, and we canceled this and this out, even though we cancel that out, there's still a 1, right? 5 divided by 5 is equivalent to 1, even though we call it canceling out. And students get confused about that. There's something still up here, right? X minus 5 divided by x minus 5 is 1. 1, right? We don't put the 1 there, it's understood. 2x minus 1 divided by 2x go minus 1. 2x minus 1 divides in itself 1 time, okay? X minus 2 divides in itself 1 time. So there are 1s even if we don't write that. Alright, so I would say, if I had some closing remarks here, I would say that if you know how to factor well, then multiplying, dividing rational expressions should not be that bad. The key is factoring correctly and completely. If you factor correctly and completely, the only next step is to cancel out common terms. And that's it for multiplying, dividing fractions. Alright, I hope this